This is the beginning of our graphing unit of the trig ratios. So to get this started, we're going to fill out a table and then we're going to graph it. If you don't have graph paper, that's okay. You can just draw a coordinate plane and draw, I'll call them hash marks. And you'd want to have 4 hash marks going up, 4 going down, and let's see, 3, 4, 5, 6, 7, 8, and maybe 8 to the left and right should be sufficient. Okay, so we're going to first fill out the table. I want you to realize that our theta are the 4 corners of the unit circle. So just to help ourselves out here, 0, pi over 2, pi, 3 pi over 2. Every time we write this down, it's helping to cement it in our memory. This order pairs 1, 0, 0, 1, negative 1, 0, 0, negative 1. And right now I'm just looking at cosine. Cosine only, which is the x-coordinate. Cosine of 0 is 1. Go up here to pi over 2. I'm at 0. Over here at pi, negative 1. 3 pi over 2, 0. And at 2 pi, I'm back to 1. When I go to graph this, my x-coordinate is theta. My y-coordinate is cosine of theta. I am going to make this 1 and this negative 1. And each of these marks is going to be a quarter of a pi, so this is 0, 1/4 pi, so this right here would be pi over 2. So this would be 3/4 pi, this would be pi, and then this would be 3 pi over 2, and this would be 2 pi. So every 2 marks is one of the corners of the unit circle. And then think of halfway, which would be right here, as those in-betweens. Those are my quarters, here, here, and here. Or that'll be there, there, and there. What I'm essentially doing is I'm taking the unit circle and I'm going to unravel it and I'm going to put it on the coordinate plane. So think of this as like a string, and we're going to take the string and we're going to put it onto the unit circle. At 0 for theta, I'm at 1, so up here. At pi over 2, I'm at 0. At pi, I'm at negative 1. At 3 pi over 2, I'm at 0. And at 2 pi, I'm at 1. Now I can also go in the opposite direction. And this would be negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. So let's go ahead and extend that. At negative pi over 2, I go this direction. I'm at 3 pi over 2, and my cosine is 0. At negative pi, I'm going, sorry, you can't see. Here at negative pi over 2, I was right here at 3 pi over 2. And at negative pi, I'm right where pi is. Again, that's at negative 1. And then at negative 3 pi over 2. So I was here, and I go negative direction, 3 pi over 2. My cosine is 0. And then at negative 2 pi, so I'm going to go all the way around this way. I'm right back here. My cosine is 1. So at negative pi over 2, I'm at 0. Negative pi, I'm at negative 1. Negative 3 pi over 2, I'm at 0. And at negative 2 pi, I'm at 1. Okay. So I'm going to go ahead and connect. Now I know it can be tempting to think this is like a giant W, but they are sort of curvy. It's not going to be like they're not really straight lines. If you if we did all the in-between points, you'd see it's got a little bit more of a curve. Now what I'd like us to do is we're going to color code this. And I'm going to make quadrant 1 on my unit circle is green. Quadrant 1 goes from 0 to pi over 2. From 0 to pi over 2, right here, that is my quadrant 1. Okay. Then I'm going to take a blue highlighter, and from pi over 2 to pi, from pi over 2 to pi, that is my quadrant 2. Then I'm going to take my yellow highlighter and do quadrant 3, which is pi to 3 pi over 2. And then lastly, from 3 pi over 2 to 2 pi, that is my quadrant 4. Now notice, when we go the other direction, from 0 to negative pi over 2, that's my quadrant 4. And when I go the other direction, I'm going to have yellow then from 3 pi over, negative 3 pi, well, negative pi over 2 to negative pi. So that's going to be yellow. And then the other direction. And then I'm going to go blue. And lastly, I will do green. And let's go ahead and label the fact that pink, I'm sorry, let's start with the green. Let's start with green, and then blue, yellow, and pink. So I kind of have like a key, like you'd have a map key. Green is quadrant 1, blue is quadrant 2, yellow is quadrant 3, and pink is quadrant 4. And there's my cosine curve. Let's go ahead and do our sine curve. Okay. I'm going to, just so I have it to be at point 2 as I go through this with you guys, I am going to go ahead and I'm going to draw the circle again. And I don't mind taking the time to do this because as I do this, it is really helping me to know this really, really well. And I'm going to list all my ordered pairs again. And this time I'm going to look at sine. And yes, I'm going to be extending my table again to have that negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, this time I'm looking at sine of theta. Sine, remember, is the y coordinate. At 0, I'm at 0. And at pi over 2, I'm at 1. At pi, I'm at 0. 3 pi over 2, I'm at negative 1. And at 2 pi, I am at 0. Just realized, hopefully I'm not being too quiet again. I have to keep remembering I've got to talk louder because of where the microphone is. So I apologize if I've been too quiet. If I go the other direction, if I go negative pi over 2 to here, this is the negative direction, my sine is negative 1. If I come around here to negative pi, my sine is 0 because it's the y coordinate. And the negative 3 pi over 2 come all the way around to here. Again, the y coordinate is 1. Oops, just put our pencil. It's 1. And at negative 2 pi, I'm back at 0. I'm going to go ahead and graph these. This is my theta. And this time, this is my sine of theta. I'm going to make this 1 again. And every other one will be a pi over 2. So this is pi over 2. This is going to be pi, 3 pi over 2, and 4 pi. 2 pi. I was going to say 4 pi over 2, which is 2 pi. Okay, and the in-betweens are my pi over 4s. That would be here, 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 and here. Okay, and then the other direction, every other one, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Okay, let's go ahead and graph this. At 0, I'm at 0. At pi over 2, I'm at 1. At pi, I'm at 0. At 3 pi over 2, I'm at negative 1. And at 2 pi, I'm back at 0. So essentially, it's like that. And then at negative pi over 2, I'm at negative 1. At negative pi, I'm at 0. At negative 3 pi over 2, I'm at 1. And at negative 2 pi, I'm back at 0. Okay. Let's do the same thing with our colors. Green can be our quadrant 1 from 0 to pi over 2. And then blue can be my quadrant 2. And then yellow can be my quadrant 3. And pink can be my quadrant 4. Now when I go backwards, let me try this on here. Quadrant 3, quadrant 4. Now when I go backwards, then from here I'd be pink. And then I would be yellow. Then blue. I'm just going the reverse way around the circle now. And then green. And I can go ahead and put my key. For my quadrants. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So now we're going to do this for tangent, and we need to remember that tangent is sine over cosine. So it's always going to be the y coordinate over the x coordinate. So let's look at tangent. Negative pi over 2, that would be down here. The tangent would be negative 1 divided by 0, which is undefined. At negative pi over 4, which is right here, remember that's where, first of all, tangent in this quadrant is going to be a positive over a negative, so it's going to be negative. And it's square root of 2 over 2 over square root of 2 over 2, so it's 1. At 0, my tangent is 0 over 1, which is 0. At pi over 4, which would be right here, it's going to be positive. And again, square root of 2 over 2 divided by square root of 2 over 2, simply 1. Up here at pi over 2, I have 1 divided by 0, so that's going to be undefined. 3 pi over 4, which is going to be right here, I have a positive over a negative, so it's going to be negative again. And it's going to be 1, because again, square root of 2 over 2 divided by square root of 2 over 2. At pi, I have 0 divided by negative 1, which is 0. And then at 5 pi over 4, which would be right here, I have a negative over a negative, which gives me a positive. And square root of 2 over 2 divided by square root of 2 over 2 is 1. And then at 3 pi over 2, I have undefined.